So if you guys have used JavaScript, you guys know that there are two patterns to JavaScript. There is an ECMA 5 pattern and then there is an ECMA 6 pattern. ECMA5 and ECMA6. ECMA5 pattern was the older JavaScript pattern which used to run on the older syntax that we have, where you will have function, name, and then variable. You will have a specific way of defining functions, prototypes. This that you're seeing is based on ECMA 6, which is the latest version of JavaScript. In the latest version, you can define your functions just like how you can define the functions for any other language. If you are familiar with C or Java, you'll see the and function implementations are exactly the same. So this makes it much easier for people to grasp it. The about ECMA that ECMA 6 makes it mandatory to have everything encapsulated in classes. So basically from ECMA 5 to ECMA 6, JavaScript is moving towards object-oriented programming. So if you guys are familiar with object-oriented programming concepts, you would know them. So as ECMA 6 is going towards OOPS, so they are incorporating encapsulation here to encapsulate the code inside a class. Now a class here, as you see, it says extends React component. The React tells it the library, and component tells it what basically entity it needs to create from that library. What I have written here is a component. Now if we just go through the code very quickly, you will see that there is a construct, that is the first function. Now constructor in JavaScript is, you might think it's a new concept, but basically if you're familiar with any other language, constructor will you use to initialize the certain values, whatever you're going to use in your project. So a constructor here basically is to initialize certain values. Similarly, you see there is a function called as tick. I'll tell you what that does. Now in React, there are certain functions inside a component that are mandatory, and then there are certain functions which are optional. So basically a constructor and the other function that you see here is optional. The one function that is mandatory in React is render function. Now basically the render functions in React tells you what it has to render on the screen. That is what it has to render on the screen. Now there is something, the way we have written the render is basically HTML. Now how that works or what that is, I'll take you in the next slide. Basically this sort of implementation of UI in JavaScript is called JSX. Okay, that's JavaScript plus XML. So this is a function React provides you. So it makes it easier for you to write simple HTML code instead of writing script code, which will require you to write something like document.get element by ID, then give the ID, then dot inner HTML, and then change the. React provides you a way of writing in JSX, which is JavaScript. So basically you straight away copy your entire HTML inside the render return function, and it will automatically compile and create a specific pattern for your code. I'll show you how that works. So first, coming to this example, so you will see that this simple example will show you the time on the screen, and it will keep on updating it every second. So if you come to the, so whenever you go in class, put the render function first, because that is the main function that will be triggered every time. So if you see here in the render function, I have created a div. Inside div, I have some text written which says seconds elapsed, and inside that I'm giving it a value. this is the way of, so it says this dot state dot seconds elapsed. Now this dot state dot second is basically considered a variable. So if you see in my constructor, there is a this dot state variable which has multiple, it like a JSON. This dot state is a JSON consisting of various values. One of them has the key as seconds elapsed, and the value initial is 0. For the first time, this dot state dot seconds elapsed, it will print on the screen 0. So UI will be seconds. Now there are two more functions here that you need to see here, which is component did mount and component unmount. Component did mount is a function that is provided to you by React. So there are component did mount, component did unmount, and component will unmount. There are 4 functions like this which are provided. Functions are called as the name suggests. So component did mount will be called once the component mounts on the browser. Component will unmount will be called when your component is unmounting, that another screen component. So what we do here is component did mount, we start a interval function. Now if you're with JavaScript, this is a time interval function which will call this method this.tick after every 1 second. So basically what will happen is once your app launches, it will start an interval function which will call your tick function after every 1 second. Okay. Now what the tick function does is very simple, as it just calls the this.set state, and basically it passes this notation that you are seeing of calling the function is again ECMA 6 notation. Don't get confused with that. This has nothing to do with it. The function and the way of calling a function is all ECMA 6. So when we pass a value called previous state to this function, and what we do is we set the value of seconds elapsed to previous state dot second elapsed plus 1. So first time when the value comes in this function, it will be 0. So every 1 second that this function is called, it will do a 0 plus 1, then 1 plus 1, then 2 plus 1, like that. So every 1 second your second value will get incremented. So on the screen you will see a time. So this is a very simple example of how a class or a component looks like. So now if I want to use this component anywhere, I can directly just create an instance of the timer class and start using it. I don't have to call for any dependencies. Okay, so going forward here, I'll show you what I was talking about. So components are complete modules on their own and can be reused by any other module. So that is the most important thing about a component. Whenever you are developing a component, you need to be careful about that. So all you need to do is, so how does a component know what it has to render? So you will pass certain amount of data to a component, and then that component should render that data. Component should not care where the data is coming from. It should only care that when it gets data, it will render that data. That's it. So if you see the example shown that I have written here, so here there is a class A and there is a class B. So now class B is, both of them are components. So I want to use class B inside my class A. Okay. So all I have to do is, whenever inside my render function there is return function, I just create a view, and inside, or for that matter, consider, instead of a view, consider it a div or a span or anything like that, and any HTML element, consider that, and then I call class B. So this way it knows that this is a class that it has to, that means it is a component that I am actually provoking right now, I'm invoking right now, and I pass data. So this data written here is a key. So I can give any key. I can give my data, my object data, anything like that. and then equal to, I pass the actual data that I want the component B to render. So now whenever I do this, the control goes to the render function of class B. Okay, and inside the render function of class B, I can directly access this data that you're seeing here by just doing this.props.data. What is props? Don't get confused. I'll tell you that, but just for here, just try and understand that this is how I can invoke any other component and pass certain data to it. How will that component use that data? That we'll see further. But this is the basic example of why you need to create components that are working on their own. Okay, they should not be dependent on anything else. So basically coming to now React fundamentals. So this was just a brief overview of what React is. Now we'll go into detail of each of these aspects. So the first is JSX. JSX is a way of writing your view or creating your view, which is much more friendlier than your method. In your normal JavaScript method, you have to write the entire document.getElement by ID, give the ID of the element, and then you write certain properties for that element, and that's how you change it, right? It provides you a way of JSX, so you can directly write your XML, that is a div inside there. Inside it, it's an H1 or H2 input field or a text field or anything like that. So it becomes very easy for you. So if you guys have any doubts at any point of time, or you can post it in the chat or questions, okay? Feel free to do that. So coming to the next concept of components, what I explained to you right now, that's a component. A component to be an individual element that basically needs to work on its own. If you guys have any doubts related to components, please, you can ask me right now if you have. No doubts? Okay, so if you have any specific doubts, you can ask me in between. Otherwise, at the end of the session also, you guys can ask me the questions. You guys can keep track of your questions. If you don't want to ask me in between, you can ask me at the end of the session also. So coming to components, a components, as I told you, is a single entity that should work on its own. So it should have the entire view. It should have all the interactions that in its own. So I just need to include that component and I should be able to use it without any extra effort. Then there are two very important things that are specific for React, and you need to understand these two things very carefully because this is the crux of React. Okay, thing is called props. The second thing is called state. Now, what is props and what is state? Okay, so if you see this example that I showed you here before, that class B was being called as data. Now this data is just a string. So you can write anything on the left side of equal to on HS. You can give it any custom key that you want. On the right side of equal to, you have to pass it the actual data, right? Now, when it goes to class B, it uses this data by calling it as this dot props dot data. Now, if your key, when you were calling class B from here, was my data equal to data, so in your class B, you will say this dot props dot my data. So basically, whatever key you are giving whenever you are invoking your class B is the same key that you will call when you are using your props. So props, if you want to understand it on a basic level, is you all would have used functions, right? Normal functions in Java, C++, or whatever. You can pass certain parameters to a function which you receive in the function as specific variables, right? And then you use those variables. The props is very similar to that. The only difference is, instead of passing those values or objects to a function, you are passing those values or objects to a class. That's the only difference. And in syntax, the only difference is whenever you want to access any of these props that you send to your component, you have to just write this dot props dot whatever key you gave when you were invoking that class. Like in this example, it becomes this dot props dot data. If you are passing any other key, you can write this dot props dot whatever key you gave. Okay, this is props. Did you guys understand what props is, or do you guys want me to repeat again? Okay. The second thing that you see here is called state. Okay. Now, what is a state? So let's go one by one. Okay. So first we'll see what is a JSX. So JSX is a JavaScript syntax extension that looks similar to XML. Okay. Concise and familiar syntax for defining tree structures with attributes. So basically JSX is the same structure that you would follow to create a simple HTML. That is your JSX. So if I show you an example of JSX, so the top example that you're seeing is how you would write. So you have a class which is a component. You have a render function. Inside the render function, you write your HTML. In this, I'm just creating a div and writing hello and then some name which I can pass to this component, right? Suppose I log in as some name, I can pass that value to this component and this will print, suppose, hello Sumit, something like that. Now, the bottom of the code that you see is the compiled JSX. So this is the beauty of JSX. So if you did not have JSX, you would have to write the code as you are seeing in the bottom side of the page, the bottom code, which is React.render, React.create element, then you give the element name and then you give the value, right? This is again so that's why JSX provides you a way to write your entire view in HTML, and then it gives you a property which you can run and it will automatically change your JSX code into JSX compiled code, so that you don't have to write it in this complicated way. You just simply write the way it is shown on the top, and then JSX provides a command which is basically JSX watch, and then you tell it what is the source of the file and what is the destination of the file that you want. And from the JSX file, it will automatically create a JS file, which will be how you are seeing the code below. Okay. So this will work really easy. As long as you know HTML and JavaScript, it's really easy for you to write in React. Okay, next. So this is your JSX. Okay. Now coming back to these examples of props is something that I explained to you what props is. State. Now what is a state? So a state basically is something or some variable, like if you see in this example here, sorry, not in this example, if you go back to this example. So what happens here is, there is a simple example where you create a state which is nothing but consider it as a JSON, okay? And then inside that JSON, you give certain variable names as keys, and then you initialize those values, okay? So these are basically your state variables, what we call them. Now, why do you need state variables. Basically, if you want that on change of any field inside your UI, something dynamic should happen, right? For example, suppose you're filling up a form, okay, which has certain radio buttons. Now, when you click on a specific radio button, the the new components loaded underneath. Okay, so before that, I think people have doubts with props. I'll explain props again once more. Okay. So props, as you can see on the screen, is nothing but basically I'm passing certain data to a component. Okay. How you normally pass your functions or values inside a function. So I have a function called add my values. I say this dot add my values and I pass two values, a comma b, right? And then inside that this dot my values, I receive them in var a or var b, and then I can do whatever I want with those values. Similarly, props is very similar. Props is passing certain values to a component instead of a function. So that is why components are a single entity. So you pass certain data to a component, and inside that component, how do you access those values? You just say this dot props. Props is a specific key. You cannot change this. So you have to write this dot props, and then you say dot and whatever key you had sent. So basically in this example, the key that I have written for class B says data. So I'm saying data equal to, and inside the brackets, I'm passing whatever data I want to pass. So it can be an array, it can be a JSON, it can be a string, it can be anything. But on the left side of equal to, it's a key. It's a string key, consider it like that. So whenever I want to go inside class B and access this value that I have sent to B, I'll directly write this dot props dot data, because data was the key that I was. If it was suppose my data equal to data, then in class B render I will write this dot props dot my data. Now this will return the value that I have sent into this variable dt. Okay, this is props work. So if you guys still have any doubts, let me know. Okay. So next, I'll move to what I was talking about as state. So before understanding state, I will give you a brief idea of how React works, or why is it better than your normal HTML or UI5 front-end applications. Because you need to understand this before you understand state. Okay. So if you have any application in which the front end is written in simple HTML or HTML5, the problems that you would usually face is that even if a single value is changed on the page, you have to render the entire page, right? That is basically you have to re-render the entire DOM, that is the data object model that you have in the browser. So even if there are 100 text fields and only one text field you have changed, if you want to show certain change on the page based on this text field, you have to re-render the entire page. Now that is a very costly operation, okay? Because if you have a lot of elements in your DOM, doing a refresh of the DOM is a very costly operation. It takes time, it takes performance, it takes resources. So it is not a very good approach to follow. Now React, how it basically circumvents this is, so Normally in your UI5 or HTML applications, you will just have one DOM, which is the browser DOM. React, what it does is it creates a virtual DOM on top of that browser DOM. So whatever was in your browser DOM is copied into your virtual DOM at the launch of your application, or at web application or mobile application. At the launch of your application, React copies everything from your browser DOM into a virtual DOM. And all your manipulations of data are happening on this virtual DOM. You will never touch the actual DOM. That is, you will never write code like document.getElement by ID and change the value. You should never do that in React, because that defeats the purpose of the virtual DOM. Whatever interactions you are doing have to happen with the virtual DOM. And then React will take care of doing a diff, that is seeing what are the values that are changed in the virtual DOM compared to the browser DOM. So React will automatically do a diff. And then if it sees that certain values are changed, it will reload only those values. So that ways you do not reload the entire DOM. Okay, that is the biggest plus point of using React. It will only reload components that have changed from the from the browser DOM at that point of time. Okay, if there is something which is still the same as it is in browser DOM, it will not be reloaded. Only those things which are changed will be reloaded by React. Okay, this is something that you need before you get into state. Okay, because state variables use this property of React. Okay, so if you have any doubt in understanding what a virtual DOM is, or why do we need a virtual DOM, ask me right now, because once we get into state, you need to understand why we need a virtual DOM and how does it do a diff and how does it reload those values. Is it clear to everybody why React creates a virtual DOM and what are the advantages of creating a virtual DOM? Okay. So next, I will explain you what is state. Okay. So state is basically, as it says, manage the state of a component. So whatever state your component is right now is handled by state variables. So basically, there is a question that says, is there any periodic time interval React maintains to compare virtual DOM with browser DOM? No. So that's a good question. So basically, the question is if there is a specific time interval after which React will constantly keep on checking if something has changed or not. Not really. React does not work on a time interval basis. React works on the principle of as soon as a value is changed, it will reload it. So it does not wait, because your app needs to be very responsive, right? So if I put a time interval of 1 second or 2 seconds, it will take that much time. So React does not work on the concept of a time interval. It will reload that specific component as soon as the value is changed. Okay, so the next question is, will React change the browser DOM according to virtual DOM? Yes, React will take care of changing once it sees a diff between these two values. It will change the values in the virtual DOM. Whatever values you had given in the virtual DOM, it will replace them in the browser DOM, and only those values, those elements will be reloaded. So that is the work of React. So you never have to worry about that. You just keep on changing whatever variables are your state variables, you keep on changing them, and then as soon as you change it, React knows that something has changed. It will automatically do a diff with the browser DOM. If it sees that there is a difference, it will replace these values there and then reload the browser DOM. Okay. Virtual DOM is not loaded on the screen. Virtual DOM is just for the reference to know what has changed. Yes. So as I was telling you when I told you about the JSX codes, somebody has asked me that is there any watcher that will track these changes? So yes, JSX provides you a watch command. So if you see here in this slide that I showed you, so JSX implementation and JSX compile. So JSX implementation is how you will write it, and you will run a watcher on your JSX. So JSX provides you watchers which will ask you the source file and what destination file it needs to create, and it will constantly keep on watching your JSX. As soon as you make any change in your JSX file, it will automatically create the respective JS file. The bottom code that is automatically created. You don't have to create that. That is the work of a watcher. Any other doubts before I go into state? Because once you understand state and props, almost half of React is you will understand that, because once you understand these two basic concepts, remaining most of just HTML and JavaScript understanding. So if you have any other doubts, let me know. Okay, so now I'll proceed to state. So now the virtual DOM concept is being used here. Okay, this is how it uses that virtual DOM. What happens is you cannot keep on diffing the entire virtual DOM with the browser DOM, right? So if you start doing that, that again is almost the same thing as using an original DOM. So basically, we tell the virtual DOM to keep checks on specific values that we want. So as soon as those specific values change, we want it to reload the view. So we first tell React which values you need to keep a watch out for. Okay. So that those values or those variables are called state variables. So whenever you initialize your class or create your class in your constructor get initial state, you will define these state variables. And then every time that you change these variables, React will only do a diff and then reload the browser DOM only for that component. So how it does that, I'll show you this. So this is an example of how you would set a state variable using ECMA 6. I'll also show you another example using ECMA 5, but first let's see ECMA 6. So in this case, you will see that there is a constructor. Sorry. You'll see that there is a constructor here. Constructor is nothing but like an initial function that will initialize your values. So inside constructor, I tell it that I want to create a state, and inside state, what values I want to keep a check on is this. So I have kept a value called as value, and I've initialized value as null. You can have n number of values inside this .state JSON. You can have as many values as you want, but always keep track that you should not just unnecessarily add values inside your state. Only keep those values which are important, and only those values which when change you need to reload the view. Normal variables and other, you can keep them outside state. Okay, so in this case I have a value and I have initialized this value to null. Now value becomes a state variable. Now if I have to access this value, you'll see in the bottom code I just write this dot state dot value. That is how you would normally access any JSON variable, right? So showing the value is similar to how you would reload the values from a JSON. The main thing comes here on this on click function that you're seeing here in the button component. So you have an on click function which basically calls a function called this dot set state, and then it tells it that what state variable it needs to set the value to and what value it has to set. So this line is very important. This dot set state function is very important when you consider state, because this is the only way you are actually going to set your state variables. By setting a state variable means whenever you want to change the value of a state variable, you call this function, this dot set state. Inside that, you tell it which state variable you want to change, and then give it what value, what new value you want to give to this state variable. Okay, so if suppose my value, there were multiple variables inside this dot state, suppose it was value 1, value 2, value 3. So here if I just want to change value 1, I just say this dot set state value 1 colon whatever value I want to give it. Like in this case, I'm giving it a string value of x. Okay. Now, once you have set the value using this set state function, React automatically calls the render function of that component. This is something that it automatically does. So as soon as you write a set state on any of the state variable, React will set the value with the new value that you have provided, and it will call the render function of that component again. So suppose in this case, inside the render method, I'm creating a button and the value is this dot state dot value. On click, I'm setting the value as x. So whenever I click on this function, it will set the value of the state variable value as x, and it will automatically call the render function. And when it comes inside and says this dot state dot value, it will now become x, right? Because I set that value to x. Yes, this state variable set method for any state variable. Okay, so basically there are two ways of setting a state variable or any variable for that matter. I could either write this dot state dot value equal to x. Okay, so this dot state dot value equal to x, or this dot set state value colon x. Both are going to set value variable with x. Both are going to do the same thing, but there is a difference in both the ways. One way is called a set state function, and one way is just writing this dot state dot value. That is very similar to how you assign this value. But if you call a this dot set state function, in addition to setting the value, you are actually going to call the render function again. So as soon as the value is set, it will call the render function again, and the view will be reflected with the new value. If you just write this dot state dot value equal to x, it will set the value of the variable, but it will not call your render function again. So even though the value is changed, the view that you are seeing on the screen will be the older one. But if I want that as soon as I change the value, it should be rendered on the screen, so I write this dot set state, tell it which state variable I want to change and what is the value I want to give it. As soon as I do that, it first sets that value into the variable and then calls the render function again. So if in the render function you are using this state variable to print something on the screen, automatically this new value will be printed. So the changes are instantaneous whenever you call set state. So does that make sense? Is it clear for you guys? When to call set state and when to just set the value? So this is an example like I showed you earlier of ECMA 6. This is an ECMA 5 notation of the same thing. So in ECMA 5, there is no concept of a constructor. Instead of a constructor, you will write a function called getInitialState. As the name tells you, it is going to set the initial state values. Inside that, you tell it what are the state variables. So here in this example, I chart number both are state variables. Now, whenever you want to set this value, you just call this function or this of code that says this dot set state items, and you give it whatever new value you want to give it. Okay. So, do you guys want to know the difference between ECMA 5 and ECMA 6, or the difference between set state and directly setting the value? Okay, I'll cover the question again. So basically inside your ECMA 6, you'll see that there is a constructor which is used to set values. These have nothing to do with React. This is ECMA 6 JavaScript, ECMA 5 JavaScript. Forget React in this case. Whenever you write any simple JavaScript function using ECMA 6, it expects a constructor. This is an optional function, but if you want to initialize any value, you will need to write a constructor. This is in ECMA 6. Similar to that, if you are using the older values, which is ECMA 5, constructor, you will write get initial state. Both the functions do the same thing. It's just that syntax is different for ECMA 5 and ECMA 6. So when you write get initial state, inside that you will tell it return, and then whatever values you return become your state variables. In this example, my state variables are items, which is an array, empty array, and chart number, which is a number, and initialized value is 1. Okay. So now whenever I want to set or change these values based on sort of interaction that happens, I will simply call the function this.setState. Then what state I have changing. So here the name is items. This name needs to match. And then I will tell it what is the new value that I want to give it. Okay. So I say this.setState items and this.state.items. So don't worry about what is this.state.items. Basically, just try and understand that this is how I am going to set the value. I say this.setState items colon some value. Okay. Okay. So somebody has asked a question for showing we have used an example like this dot state dot value, which denotes string interpolation, which okay, so I think you guys are asking me about this example. So basically, if you see this example, it's the same thing. Whenever you are accessing a value, it's as simple as accessing a normal JSON value. This concept of accessing this dot state value will be common across all forms of JS, be it Angular JS, be it React, be it React Native. Okay. This form of accessing this dot state dot value is basically accessing a JSON value. So it is nothing as specific for React. Whenever you want to use any state variable, you just say this dot state dot the key that you gave inside the variable. Here in this example, inside this dot state, I gave value as the key. So whenever I want to print something which should reflect that value, I'll just write this dot state dot value. Does that make it clear? What benefit we have of using React.JS or AngularJS? I have not used AngularJS 2.0, the latest version, so I won't be able to comment on that. But as far as React is concerned, I found that using React, the concept of state and props specifically is something that will help you out a lot when you are using React. I'm not sure if AngularJS has the same concept of state and props, but once you get familiar with the concept of state and props, you will actually find the work becomes very easy. Asking, okay. So inside the button, I have written curly brackets, and inside that I am writing this dot state dot value, right? So whenever you are writing JSX, it understands only HTML. Okay. So if you are writing like button, H1, H2, span, your JSX understands that. So basically, it has an HTML kind of a thing. Consider it that. So the JS compiler understands that if it sees HTML, it has to change it to React.create element. But there will be some things which will be dynamic, like data that you want to show or something like that. You do not want React or JS compiler to basically try to change this also into an element. So whatever you write inside curly braces is exempt from the JS compiler to change it to React compiled code. So this dot state dot value is going to actually tell it that I'm actually trying to access a value. So your JavaScript code you can write inside curly braces, and that will be exempt from the compiler which is going to change it into React compiled code. So that is why we use curly braces. Is that clear? Okay, there is one more question that I want the state to be a private property. How can I do it in ECMA 6? See, state by itself is a private property for that class. A state variable is not going to be accessible outside the class. So itself, state is only specific to that component. If you want to pass the value of state variable to another child component, you need to pass it as props. But in that case, state variable does not change. So the question is that if I want the state to be a private property, how can I do that in ECMA 6? That's what state by default is a private property. If I am creating an object of square or I'm referencing square, I cannot do square dot state dot a value. I cannot do that. State by default are only available for a class. If you want to pass any value to a child component, you pass it using props, like how I showed you. Does that make it clear? No, state is a keyword. Question is, can I use any other name instead of state? Will it change the definition of state? Repeat. So basically, state, just like how props is a keyword, state is a keyword. You cannot change state to something else. You cannot write this state equal to something. In that case, it becomes just a normal JSON. It will not be a state variable. For React to know if it is a state variable, you have to write this dot state. That's a keyword. Okay. Any other doubts? Okay. So we are running quite slow. I'll just proceed to to the next thing that is there. So I'll show you the examples after this. Another thing which is basically how you set a variable, right? So in ECMA 5, you call this dot set state. You pass the key and the value, and inside your render function, whenever you want to print that value, you're just going to write here. If you see, okay, inside this function, you see that inside the function, I say this dot state dot items dot map. Okay, don't get confused. What does this map means? Map is basically, if you are familiar with normal JavaScript and data binding, you will understand that map can be used on any array. What map does is, if my array has 10 objects, I don't have to write the UI code 10 different times. I will just write one code for one object, and that will be replicated for all those 10 values. Okay, that is what a map does. So basically, I write, suppose there are 10 cells that I have to create, and inside each cell there is a heading, a smaller heading, and then some other text and an image. Okay, so I will just create this UI once, and then I will tell it that map this UI to this array. So as many objects are there in that array, that many UI elements it will create. I don't have to do that. So that is basically this dot state dot items dot maps. So basically your items is an array. I tell it that map this array to this UI, and each item, so as it iterates through the array, it will automatically iterate through the entire array, and the first object, second object, third object, all of them will be set into this variable called item. You can give any name for this variable, and the second variable is always the index. So if it is seeing the 0th object, the index will be 0 and item will be the object at index 0. Okay, so when you come inside this, whatever code is written inside this map function will be called as many times as the number of elements are there in the array. Okay, so in this case, it will create this div, image and div as many times. So if there are 10 elements, it will create 10 UI blocks, each being a div containing an image. And item dot content, right? So basically is each object. Now each object inside that array should either be a JSON or a simple string value. Preferably you should try and keep it as a JSON, so each item can have multiple values. So whenever I come here, I directly access item dot some key, and that key will give me the value for each object. So when I am doing this item dot content, for the 0th object, it will print the item dot content of the 0th object. Then for the first object, it will print the value is for the content. Then again for second, then third, then fourth. It will keep on going like that. Okay. Okay. Now there's another thing in React which is called Flux. Okay, so I won't go into much detail into this, because this again is in itself is a huge basically module itself. This is an entire architecture that basically you can incorporate in your React. It is not mandatory, but it is good if you're going to have a big application. It's good to have a Flux architecture in that. What that Flux architecture does, I will take you through this briefly. So basically, it makes the data changes. Like right now, till now, understanding state and props and virtual DOM, we saw that the only way of sending data to a component is okay. Now this becomes slightly difficult when you have a lot of children or a lot of different components which do not directly interact with each other. Okay, so in that case, you cannot send data from one component to the other component. There is no current way. So a Flux architecture helps you circumvent this problem. What it does is, a Flux architecture, this is the structure how a Flux architecture works. So inside a Flux architecture, you will have a central data model. So as I was talking about MVC pattern, model view controller, similarly in Flux, there is a view and a model. So the view is basically your component file, right? That becomes your view. A model is one file which will contain all the stored objects that all your components are trying to access. So if you're familiar with singleton framework or a factory framework, something like that, consider store as a singleton data model class. So if my application uses 10 objects across 20 components, so all those 10 components or all those 10 variables I will assign in store, and I will write set for each of them. And each of my components, when they want to access any variable value or any value for that matter, will directly call the getter or setter. So in this case, since this file is common across all components, even if one component makes a change in one value, that is reflected for all components. Okay, so that's why it's a singleton kind of a class. So it's a central repository of data which every component has access to, and whenever any component makes change, that change is reflected for all components. So they can automatically take whatever action they want to take in their UI when some data changes. Okay, so if you see this structure here, there is something called as an action. So if you guys are familiar with event dispatchers or event emitters, you will understand this better. Okay, so somebody has asked me a question. We have written render function which returns HTML with data. So we don't need an HTML file here. And also how the render function will be called automatically and render the HTML. Okay, so you don't need a separate HTML file. It's not required, but if you want, you can have a separate HTML file also, which you can include inside the function of render method. Okay, so it's possible both the ways. The thing about why you should not have a separate HTML file is because each component needs to be small and granular enough that it can be reused as a single entity. Either you'll create multiple HTML files with small codes of HTML that can be created as one single component. If you want to keep one big HTML file, it's not basically suggested that you create it as one component. It is always better if you split your entire view into multiple smaller components. That way, managing the virtual DOM becomes easy. Okay, so if I have a component with only 2 fields, if I do a reload, it will only render those 2 fields. But if I have again a component which has entire 100 fields, if I do a render or if I change one variable and I call render again, it will render all 100 fields. So it's always better to create a component at the most granular level. Okay. The other thing that they have asked is how does the render function will be called automatically. Basically, whenever you call the set state function, the render method is automatically called by React, because React knows that whenever you are calling a set state method, you are changing a state variable. That means I need to reload the view. Okay, so as soon as you call the set state method, React will automatically call the render function again. You don't have to explicitly call. And more importantly, you should never explicitly call render function. Okay, you should let React take care of calling the render function. So render function is called for the first time when you load the component, and after that, every time that you call a set state, it will again call the render method automatically. Does that make it clear? Okay. So coming to the Flux architecture, so right now, as your normal flow works, that is, your parent will pass certain props to your child, or one component will pass certain props to another component, then that can pass certain props to a third component. But there is no way right now of communicating back. Right? Component A sends some data to component B. Component B currently has no way of sending some data back to component A, right? That is the one drawback of React. Okay, so the flow in React is always in a single direction. Now this makes things easier to understand, but it requires you to write a bit more of the code. Okay, so React provides you a Flux architecture so that you can send data back. Okay, Flux architecture is provided so that you can handle passing data from one component to the other component. How it works is, so as I told you, there is a store, which is a central data model class, and then there is a dispatcher. Basically what happens is, whenever you want that other components should take some action because I have made a change, you dispatch event. So if you guys have used event emitters in JavaScript before, you would understand this better. Event emitters or any sort of event, when it is emitted, is a broadcast. That is, I will send this event to everybody. That's how normal event emitters work. And whoever is listening to my event can take the appropriate actions. Other classes which are not listening to my event can ignore that event, but I will send it to everybody. In this case, in case of Flux, the store file registers for this dispatcher. Okay, so basically whatever events dispatcher is going to emit, store is going to listen to that, right? So suppose my view, or my I made from the login page, I entered my login credentials and I'm going to the next page, which is my home screen. In that case, my login page will emit an event telling that I have successfully logged in. Now you can load the next view. This request will go to the dispatcher. Dispatcher will dispatch this event. Since store is listening to dispatcher's events, it will automatically, you will have to write the code in store to tell it what happens when this specific request comes. In that case, whenever the dispatch request for login successful comes, I will have to load the home screen view. So then store tells the respective view that now you are going to be loaded on the screen. That view will call its render function, and then again tell the dispatcher that I successfully rendered. Now if that view, inside that view you interact something and you want to go to the third view, again your view will talk to the dispatcher. Basically your view will trigger an action. That action will talk to dispatcher that this action has happened. Now you do whatever you do in case of an action. Will pass that information to store. Again store will see, okay, what do I need to do when this action occurs, and then it will take that propagate action and call the respective view. So this is a very basic flow of Flux. Flux has a lot more things into it. I would not go into the details of that because that itself will be a big session in itself. But this is the basic structure of how React allows you to communicate or pass data across components using a store and a dispatcher. Okay. So basically these are your concepts or overviews of Flux concepts. So basically there is a single dispatcher. The dispatcher is a central hub that manages all data flow through Flux applications. So basically we are streamlining the entire data flow. There is a central place through which all data goes. So whatever routing that we want to do of data to specific views, we can write it here. Okay, it's a single place through which flow will happen. Second thing, there is a store. Store contains application, state, and logic. Like what I told you guys, it's a data model. Something similar to a model in a traditional MVC, but they manage the state of many objects, right? So basically, these are managing tables across components. So if I, as one component is changing some value, component 2 is dependent on that value. Whenever it fetches the value, it will get the new value that I have changed. Okay. Then there is something called as actions, which is the dispatcher exposes a method that allows you to trigger a dispatch to store and include a payload of data, which you call as an action. So action is nothing but whenever you want to emit something, done something, you want to send this information along with some data to dispatcher that I have successfully logged in, or I have made a change on the home screen, or I have clicked a button, something like that. You pass that information in actions, and then action will pass this information to dispatcher. Dispatcher will pass this information to store, and then store will pass this information to the respective view. Okay, this is the kind of structure that works for Flux. Are you guys clear? Before I move to React Native, are you guys clear with what is the concepts of React? What is store? What is props? What is state? What is virtual DOM? What are the advantages of React Native over normal HTML applications? Are you guys clear with that? Okay, because these concepts will be used in React Native also. So basically your props and state concept are reused in React Native. Okay, so you need to be clear concepts of how do I send props and what is a state and how do I manage state variables. You need to be clear with this. Flux, if you want, I can take you guys through it again once I'm done with the session, because let me first complete React Native, then I'll again come back to Flux, because Flux has a certain amount of understanding in itself. But it's not a mandatory thing for creating normal applications. A normal, simple mobile or web application you can create using React without using Flux architecture. Okay, it's just that Flux streamlines the entire process. So I will proceed to what is now React Native. Okay. So basically now what we were seeing, right? So that is, it's an HTML or a UI component on top, and then there is a middle layer that is mobile, and there is the actual device. The other type of applications that you would generally hear about are called native applications, right? So native applications for iOS are written in native iOS code, which is Objective-C or Swift. For Android, it will be written in Java, right? So for each of the specific platforms, native applications are written in native code. So this causes some problems, because if you have one application which is available for 3 or 4 platforms, you have to maintain 3 or 4 code bases. if there is any bug, you have to fix it in 3 or 4 code bases. You have to manage 3 or 4 teams, right? So there are certain amount of problems with having native applications with native code, okay, because it is split between platforms. Now React Native, what it does is it provides you a way of writing one set of code and then like a native code, like how React provided you a way of writing one single code which will be rendered on all platforms. React Native provides you the similar freedom of writing single code which will be then rendered in iOS and Android, and it will be rendered as native components. What I mean by native components is it will not be using any HTML or custom components. It will use the native UI elements that your normal iOS or Android uses. So how a ticker looks in iOS, or how a scroll view looks in iOS, or how a tab bar looks in iOS, your view will look exactly the same as native. Okay, so it will look how it looks in iOS, and it will look for Android how normally your native apps look in Android. To React, since it's HTML, it will look the same across all platforms. Okay, whatever HTML code you are writing, that will look same across all platforms. But when we come to React Native, it is going to render the code into native elements based on the platform. So this is the first basic difference that you have to understand between React and React Native. React is HTML, React Native is native code. React looks the same across all platforms. React Native will have a native feel for each platform specifically. Okay, React, you are actually creating all your elements using HTML. React Native, you are creating all the elements using native code. Okay, this is the basic difference. So basically, why go native is you have to write only one code for Android and iOS. So right now, React Native supports only Android and iOS. Okay, that is one limitation that is there still. But if you are using only these two platforms, React Native provides you almost all the functionality that you would normally need for writing a native application. So it renders native UI elements instead of HTML elements, direct interaction with device hardware. So there is no middle layer of which will basically interact with the hardware. Your code directly interacts with the hardware, so that increases your performance and there is no lag. Okay, and makes the best use of native immersive experience. So generally, whatever native apps you use in your platform, be it iOS or Android, React Native will give you the same look and feel. So you will not feel alienated by what do I do with this control, because that will be the same control that you are used to in all your native applications. Okay. So what is React Native? React Native basically lets you mobile apps using only JavaScript again. So the good thing about React Native is you only need to know JavaScript, okay, and HTML. The only thing is the syntactically what elements you create differs. Like how you would create a div and a span and various other HTML elements in React. In React Native, you will create view and specific modules, view, text, scroll bar, list view, these things, which are going to correspondingly relate to native elements of Android. If I write view, it will automatically check what does a view correspond to in iOS. So it will automatically change it to a UI view. It will automatically check what does a view correspond to in Android, and it will automatically change it to that. Okay, so you are writing code in consider it like a middle language. Okay, so you are writing code as a middle language, and then that language that you're writing or syntax that you're writing your code in is going to be interpreted by your React native compiler, and it will automatically understand that, okay, my platform is iOS, so view means this in iOS, and it will automatically create the iOS native view. Is that clear? Okay. So that's what I was saying, that the syntax or some things that you will see here is very similar to React. So you need to understand React before you proceed to native. Because once you do that, the syntactically most of it will be same. Only the common elements that you're going to use might be a little different, but state, props, and syntax all remains the same. Why use React Native? Again, the same thing that I told you, that with React Native, you don't need to build a mobile web app. So firstly, you are building a native app that has its advantages in performance, in user interaction, in the look and feel, in the experience that you will get, because he will be used to the native applications that are there. When you're creating an HTML application, he needs to get used to that HTML rules. They're not native, and the look and feel will be same across iOS and Android and BlackBerry and Windows. So that again gives you a certain problem areas. Again, since it is a hybrid application, it will cause issues with performance, because basically first your UI interact with Cordova, then your Cordova will interact with your device, then your device will interact back to your Cordova, and Cordova will interact back to your UI. The three-step process. Instead of that, if you go for React Native, your native code directly interacts with your device, and there is no middle layer, so there is no lag. It's very fast. Okay. And basically what it says is, if I write an application in React Native and I give it to you, you will not be able to tell if this app is written in native code or React Native, because it will give you the same experience. Another good or important feature of React Native is hot reloading. Okay, so normally whenever you are writing your native application in iOS and Android, you make some changes, you have to compile it again and run it in the simulator or device. You have to compile the entire application again, right? React Native lets you with an option of hot reloading, in which you don't have to constantly compile and run the application again. React Native does it for you. Okay, as soon as you make some change and you save the file, React Native automatically reloads the app. Okay, so that is something that is very, very beneficial, especially when you are debugging your application or you're making minor UI changes. You don't have to create the entire bundle in case of iOS, an entire app, and then load it in a device or the simulator. So it will automatically do all those things for you. You just have to make the change and save it. As long as the syntax is correct, it will reload. The other thing that you can see from these options, these are the options that you will generally get in your device. Okay, so React Native has something called as a shake menu. So in order to get this menu, you just have to shake the device and you will get this menu. When you get this menu, you see there are a lot of options. You can explicitly do a reload, which will actually fetch all the bundles again, create the entire app, and then reload it from scratch. Okay. You can remotely do a debugging on your application. That is, you can connect it to your laptop and then debug it using Safari or Chrome. Then you have live reload and hot reloading. So these are the two operations that will help you a lot whenever you are interacting with React Native. Okay, you don't have to reload the application every time. Whatever screen you are in at that point of time, it will reload that view based on your new changes. Okay. Basically, and apart from this, React Native also provides you a way of running native code, because just like Cordova, React Native understands that there will be a lot of functionalities that React Native will not be able to. For example, React Native will write or give you components that are mostly common. across, or that can be translated into Android and iOS both. It will also provide you Android specific and iOS specific components also. But still, if you want to create your own custom component using your native code on iOS or Android, you can do that. You just have to include that file and like how it's done here. So it's easy to be a part of your, so if you have an existing, suppose native application, and you want to change it to a React Native application, it makes it very easy to just directly reuse your native application files and then port them in a React Native framework. Okay. So this is the actual structure that you'll see how a React Native application is created. So you see here that there is something called as your app code. Now this is the code that you will write like this, how we are seeing here, that is a view, there is a text. Similarly, you can have multiple components that are being called inside this, same as React. So you can have multiple components, you can pass data to those components using props, you can have state variables, you can manage the view based on state variables. Whenever a state variable changes, it will call the render method again. These concepts remain common across React and React Native. Only the rendering part will change. Okay, so here we create a view. Inside that we call this greatest component in the world, which is your native code file, as you see here, and then React Native code also, which will be automatically translated to various components. So you have your app code, then you have native JS library. So basically, whenever you are going to set up a React Native environment in your system, it actually installs around 160 MB of React Native libraries by default. Okay, so whenever you do a React Native install, when you're creating your first project, it will download around 160 to 200 MB of React Native libraries. Okay, and these are the basic set of libraries. After that, there are multiple extra plugins available by MIT and various other contributors, plus React, plus in your NPM modules, that you can use for various smaller components. Those you can install later on, but the first time that you do that, it will install a certain set of basic React Native libraries. So those are your libraries here. Now this is encapsulated inside your React.JS, because the entire code structure that you see here is exactly the same as how it is in your React.JS structure. Okay. Then on top of that, you have a JavaScript engine, same as how you have a JavaScript engine in React, which will automatically convert your JSX into JS. Similarly, in this case, it will convert your JSX of various components into the respective JS components. Then you have a React Native library. Now this is very important because this is unique to React Native. So once it creates your JSX compiled version, then your React Native library picks it up and then understands that for which component it needs to create what native component. I create a view, React Native library picks it up and understands, okay, since I am on an iPhone, I will create a UI view, which is the native view for iOS, right? So that work is React Native library. Using a text field, then React Native library automatically understands that, okay, since I'm on iOS, it will be a UI text field, which is the native text field for iOS. Okay, and this is packaged as a native application. So when you get an application, you will not be able to make out normally if it is made on React Native or a native application. Okay. Now these are the small set of the UI components that are available from React Native. So some of them will be common across iOS and Android, and some of them will be specific to a specific platform. Generally, this thing you can check in the documentation or you can check it in the name. One good thing is React Native has very good documentation. React and React Native, both of them have very good documentation. So any doubts that you have, if you just go through the documentation, it will clear you everything. All the props, all the parameters, all the events event handlers, everything that a specific component has. It will show you everything. So as you see here, there is some activity indicator, a date picker, image, list view, map view indicator, and a lot more. I have a few examples up ahead of 2 or 3 components and how they will look basically. And on the right side, if you see, like, there is a status bar iOS. There will be an activity indicator iOS. So there will be certain components generally which will be only specific to a specific platform. Okay, why they did that is because generally there will be certain properties which iOS supports which your Android will not support, or certain properties which Android supports which iOS will not support. For example, if you consider the case of shadows, okay, so shadows is not supported by both the platforms equally. So when you go into React Native and you want to use shadows, you will have trouble with both the platforms. Okay, not both of them will support it. Certain properties iOS will support, certain properties Android will support. So that's when you either need to take a call, either you create your custom component, or you use the existing activity indicator which is common for both and which accepts only specific common properties, or you use an activity indicator iOS and you create a different activity indicator for Android. So it depends on how you want the native user to get the feel, what all functionality you want to give on that component. Okay, is that clear? Does that make sense? Okay, so similar to that, there are some things that you need to know about React Native. Okay, because React is HTML. So as long as you know HTML, you are almost good with React, right? So all your CSS properties, all your height, width, styling, border, margin, padding, all those things that you have in your normal CSS and HTML will work in React since it is HTML. But in case of React Native, since it is not HTML, the way CSS is applied is very different. So not all your HTML CSS properties will be available here, and there is a specific syntax of writing the CSS properties here. Okay, so since, like, for example, in HTML you can give, suppose, margin left as 10 pixel, right? But now when you come to native, you cannot give the code in pixel because it is not HTML. You have to give the code in numbers. Now these numbers will correspond to different devices, right? So that is where you will have a major difference between React and React Native. That is in your layout and in the way you show it on the screen. So that I'll take you through that in the next few slides. Before that, try and understand that basic things that you need to understand for React Native is state, which is same as React, how the state works in React. Props, which is the same as how props work in React. There are two new names that you will be reading, which is flex and flex direction. Now these are two things which are specific for React Native, and you need to understand these creating your UI layout or your view layout. Okay, as you see in the small image, so this is just a basic thing. I'll take you through in the next one. So if you understand flex direction is nothing but it tells the compiler that whatever elements I'm adding can have either direction row or column. So if I give the flex direction as row, whatever elements I'm adding inside that component will be added in a row. If I tell it the flex direction is column, all the elements that are being added will be added in a column. Okay, it's very simple to how in your HTML you have hbox and vbox. Okay, then you see in the second thing you have something called as justify, and the third thing is align items. These things are nothing new. These things are the same as what you have in your HTML. You have a justify content and align items, which will be left, right, center, and all that. It's just that in React Native, these properties will take only certain values. They will not take all the values that your HTML takes. Okay, so these are certain things that I'll take you through. So basically, what is flex? Now, understanding what is flex is very important in case of Vue. Flex is a way of styling. Okay, so if I want to give the width of certain component, I have two ways. Either I hard code the width, suppose as 250 or 300. But in that case, that width remains fixed across various device sizes. So if I run it in a smaller screen or a bigger screen, if I set it to 150, it remains on both the screens. Instead of that, we want an adaptive layout, which will take the entire screen, and then based on that, it will create the view. So it is something very similar to how you use percentages in HTML. Okay, so flex is very similar to that. It automatically understands the entire height and width, and based on that, it will create your view. Now, flex equal to 1. So as you see in the code here, suppose, as I say, style is basically a keyword, and inside this you will pass your CSS styles that you have. Okay, so the way I have mentioned here is like background color, flex. This is called as inline styles, because I am initializing, or I am showing all my style properties here itself in the code. If I have also an option to create a different class or a variable called styles and give different keys to that, like how you do in an HTML. And here I just write styles is equal to my variable dot whatever key I want to set this to. So if I have set a key as view style 1, so here I just say style is equal to styles dot view style 1. Okay, that's another way of modularizing your code. Now if you see here, the parent style says flex 1. Okay, so flex 1 means whenever you have to give a flex property to some children of a parent. So like in this case, the 3 views inside are children of outer view. Okay, because they're inside it. So now whenever you want to give some styling properties to the children, you have to make sure you first tell or first set the flex property of the parent. Okay, so when you tell that parent as flex 1, what that means is whatever is the available screen width, the parent is given the entire width and height. Okay, now whatever calculations that children are going to do is based on this baseline that parent flex 1 is this entire thing. Okay, now when you are actually creating various children or child elements, when you give them a flex value, it automatically becomes like a percentage. So in this case, if you see, the first view says flex 1, second says flex 2, and third says flex 3. Now what this basically corresponds to in simple terms is that the third view will be 3 times the first view, the second view will be 2 times the first view. Okay, so the screen will be divided into 6 components. Consider it, and since I have given this by default flex as, since you have not given the flex direction, it has automatically taken the flex direction as column. So it divides the entire height into, it gives one of those 6 widths or heights to the first view, 2 of them to the second view, and 3 of them to the. So this is basically how you will actually do this. Instead of doing this, I could also write, if parent style was suppose 1, and I could also write here, so if the parent style was suppose 0.5, right, can the children view as flex 0.1, 0.2, and 0.2. So basically whatever I am giving flex to the children is in reference to the parent, and whatever values of these children are there, they will be relatively checked. So I have 5 children and the flex value start from 1, 2, 3, 4, 5. So the one who has flex value of 5 will have dimensions of 5 times that of the view which has flex 1. Okay, similarly, if I'm giving giving flex 1 and I want the other one to be half, I can give it as flex 0.5. If I want the third one to be 1/4, I can give flex 0.25. So this is basically a relative comparison of the flex values and then decides how to render the view. Do you understand this? This is one base of flex that you have to understand when you come to React Native, of how to give what flex value. Is this clear for everybody? Okay. So this is a very simple example because the entire view is split into just 3 views. Consider a complicated example in which you have multiple views. So you will give different flex directions, different flex values, and all the children will basically set the flex values based on the parent. Yes. So there is a question that if we define another view inside the child view, it will again be proportional. Yes. All child views take the parent dimensions as 100%, and then they start calculating based on that. So if your parent was a small div of or a small view of just 100 cross 100, and your children that said flex 1, flex 2, flex 3, it will again just split that 100 cross 100 square into a similar view that you're seeing here. So whenever children are given a flex value, they consider their parent value as 100% and then they start calculating based on that. Is it clear? Okay. So this is just a simple view that you see. Now you can create various complicated views using this. So you can have various parents with various small children inside it and give flex values and all. So initially when you're doing it, you might think it's a little bit complicated, it's a little bit cumbersome, but trust me, once you get a hang of it, this works like a charm, because your flex takes care of your orientation change, your flex takes care of if it is a phone or a tablet or a desktop. All those things are taken care by this, and you don't have to do anything as long as you have created your view properly. You have not hard coded any heights and widths or any dimensions. Your entire application will work with this. Okay, there is another question, how to manage width with flex. Okay, so like I told you here, that there is something called as flex direction. Right? So by default, since in this example flex direction is not there, so the flex direction is not taken. All the values are just added as a default, which is one after the other after the other. If I give a flex direction as row, then it will add these components in different rows. Okay. If I give a flex direction as column, it will add these values in a column. Once I go take you through the next examples, you will understand what I'm saying. So this is a flex box. Okay. So like how you were asking, how do I change these views into width? Because the previous example, it was height. If you see this example, it's the same thing. It's just that I have given a fixed direction here on the parent view. What that does is it tells it that whatever children components I'm going to add them in a row. Similarly, if I give it as flex direction column, it will add all these smaller children views in a column. Okay, so this is your flex direction. This is also very important. Whenever you are creating a parent, you will ideally have to give a flex and a flex direction to tell in what orientation you need to add the children. Okay, so you can have a parent inside a parent, then you have a child which is again a parent of another child, like that. So your flex directions can vary. A flex direction of a parent is not copied onto its right. So if your parent view has flex direction row and your child view wants to create two smaller views again, which should be in a column, you can give a flex direction in your child view as column, and then whatever are the children of that view will be added in a column. Okay, first thing is since you are writing it for native is only available for iOS and Android, so the question for desktop doesn't really come in that easily. But yes, if you are creating, if you're thinking of it in a form of a tab or a tablet, yes, your flex will be retained proportionally across various of mobile platform. So if you are viewing it on an iPhone 4 or an iPad, it will be proportional. If 50% in the iPhone, it will be 50% in the iPad. Does that answer your question? Okay. So if you see the example here, this is how I can hard code the values. So I have given width as 50, height as 50. Okay. So when I do this, it will automatically hard code these values, and these all views are added in a. This is the second. So similarly, if I give here a column, all these views will come one under the other as a column value. Okay? So it's very simple. It's just like how a vertical box or a horizontal box works in HTML. The other thing that you'll use generally is justify content. So now these are again your HTML properties, but then what values they take is specific for React Native. Okay, so generally whatever values your CSS properties take in HTML will, all of those values will not be accepted in React Native. So here I have given the flex direction as column. So all these elements or all these views are added in a column, and I give them justify space between. Now these are specific key values that you have. So you have various values like flex start, flex end, space between. So all these values you can go through when you're going through the documentation. So each property of the view will accept a specific set of values. And the best thing about React Native is whenever you get an error, it will not just show you where the error occurred, it will also show you the possible solutions. So if I suppose write justify content as left, okay, and because left is not a recognized property for justify content. So when I run that code on my mobile, it will show you justify content has wrong value, unrecognized value left. Please use the values from this list, and it will show you the list of all the existing values that you can use. So React Native debugging is extremely easy, and it even tells you the solution for your problems. Okay. So in this case, I have given justify content as space between. So basically it justifies the entire column height and gives these values as space between. So it will automatically adjust to the space. Okay, pretty straightforward. Similarly, there is something called as items. Okay, these are again your HTML properties, but again, some of the values like center is a value that is accepted in React Native, but your some properties might not be accepted in React Native, so you have to be careful with that. So in this case here, I give flex direction column, justify content center, and align item center. So when I do that, all the items are now, since justify content has brought it to center and aligned items has brought the entire thing in the center of the screen. Okay, so by tweaking these three properties, which is your flex direction, justify content, and align items, you can create the most complicated of that you want to create on your UI. Okay, so after this, I'll take you through some examples of code how the native elements are rendered. So till now, if you have any doubts in align items, justify content, flex direction, flex layouting, let me know. Everybody is clear with flex, align items, justify content, flex direction and flex, because flex and flex direction is something that is key to React Native. So when you are developing your applications, you have to be very careful with this. Your flex and flex direction is something that will help you with creating material design views also. So the same view, when it is rendered on your tablet, will be proportional to tablet, and when it is created on a smaller phone, it will be proportional to the smaller phone. So you have to be very clear with how you create using flex and flex direction. Okay. So I'll now proceed and I'll show you some small examples. There are various UI elements that I showed you initially, right? So there are certain examples that I'll show you that how easy it is to create a simple view. Okay, before I think people are not clear with flex. So this, if you want, I'll explain again. So if you see this example, flex is basically defining the entire width and height of a view, or the width and height of the parent, and based on that creating a layout inside that. Okay, so when you have a parent which has a specific height and width, suppose 100 cross 100, inside that you write two views and you give them flex as 0.5. So it will automatically split the view into half for each of them. If you give flex as 1 and 2, so it will give 1/3 value to the first view and 2/3 to the second view. So basically it will split proportionally amongst the views based on your flex values. Okay, flex value is any number as long as it is proportional. So you have to be the parent flex value, or if your one child's flex value is 100, you can give 200 to the second one, and that will be twice of that. So the number values don't matter, the ratios matter. Okay, so you have to be careful with that. You can give 0.1, 0.2, you can give 1, 2, you can give 1000. So it's up to you. It's only that the ratios will matter. Okay, now this is your flex. Inside flex, again, there is something called as a flex direction. If you give flex direction as a row, you will have all your elements in a row. If you give flex direction as a column, you will have all your elements in a column. Straightforward. Okay, somebody has asked me, can we render separate CSS? So like I told you before, that the style written here is called an inline CSS or inline styling, which means that it is hard coded here. Instead of this, I can write a separate style class or a separate style class and assign it to a variable, and multiple style classes for that matter, and I can give whichever style property I want to this value. So if I want to view as a specific style property whose name is style1, so I can just say style is equal to styles.style1. It is basically the concept like how you have classes and IDs concept in your HTML CSS. So you create a class and you give the class name to, you say add style class and give the class name to one object or an element, and it automatically searches for that class name and sets whatever properties are there to that element. It is similar to that. You just give it the name and then it will automatically search for that whatever properties are set and apply it here. You can also do it programmatically, you can hard code it, or you can keep it in a separate file. Okay, and a function here which will basically return you the style properties. So many times you will have certain values which, based on certain conditions, you would want to change the view. Suppose I click on a button, I want it to change from red to green. Okay, so on the function change, you can set a style and you can assign that style to this value dynamically. So I create a variable and it as background color blue. If basically on click function, I define it as if it was orange, turn it to blue. If it was blue, turn it to orange. And I give this variable inside the style property. So whenever I click, it will toggle between these two styles. Okay. Any other doubts you guys have before I show you the examples? Okay. So simple examples. This is just a simple class inside which I am creating a text input. So basically, inside React Native, there is no concept of div because it is not HTML, it is native. So everything is a view. Whatever you use as a div translates to a view in React Native. So you create a view, you give it certain properties, you create a text input. There are certain properties for text input that are automatically provided for you. All these properties are available in the documentation. So there will be hundreds of properties that are there. There will be some properties specific for Android, some properties specific for iOS, some properties which are common for both. So you can choose which and all you want to tweak. So here I just given the style and height as 40, placeholder, and then on change text, I have given a function. So whenever the text changes, it will trigger this function. So you'll see that inside the text, what I'm saying is this dot state dot text split based on space and map to the word. Don't worry about the inside example as such, but basically try and see how you will create a text example. Okay, so whenever you have on change text, here you can trigger a method, whatever method you want to trigger. Once whenever the text changes, you can do in that method. Inside your render method, you can print your placeholder, you can print the state variables. So we were printing state variables in React. Okay, so this is pretty straightforward as compared to that. Similarly, there is a scroll view. Now these are the most basic elements that are available. Okay, so there are two things. One is a scroll view and one is a list view. So just two more things and then I'll wind up after this. So there is a scroll view and there is a list view. A scroll view is used, both of them are scrollable, but the only difference between scroll view and list view is that scroll view will render all the elements or basically load all the elements that are there, even those that are not visible on the screen. It will keep them loaded. So if you have a list of suppose 200 or 500 elements, it's better not to use scroll view, it's better to use list view. List view will only render those elements that are on the screen. And as you keep on scrolling, it will keep on rendering. So basically it is something like how you reuse cells in iOS or Android. So it will keep all of those elements in memory. As for scroll view, it will keep everything in memory. Okay. Then again, the similar thing, drawbacks is scroll view is very good in scrolling, it's very fine. But for list view, there are certain properties that you can set so that the scroll becomes smoother. But again, if you have too many values, like 100,000 values in a table view, it will again slightly get slower when you're scrolling. So there are certain properties that list view provides you, which you can use to circumvent these things. Okay, so this is a simple example of a scroll view. You create a scroll view, you can give any view inside that scroll view. This is an example of a list view in which you create the list view, and then inside a list view, you give it a data source, and then you tell it render row. The render row is a predefined function inside list view that is called for every row, and it is automatically called for as many objects in your data source. So if your list view has 10 objects, if your data source has 10 objects, your render row will be called 10 times. Okay, and it will only render for those many objects that are visible on the screen. So this concludes your list view. These are a few references or materials that you can keep or go through if you want to understand the React Native, Flux architecture, all these things. And that's mostly it. If you have any doubts or any questions, you can ask me now. Or if you want me to go through any specific module again, you can tell me. Anybody has any questions? So if we have no questions, then I would conclude this session here for React and React Native. So basic understanding, a small overview is React is for your hybrid applications, web applications where you are going to use HTML. React Native is for your native applications which are going to use native elements, that will be specific for iOS and Android separately. Your React will have HTML elements, so they will look the same across various platforms. React Native will use native elements, so they will be different for iOS, different for Android. React Native will have slight performance issues compared to native because there is a third amount of layer in between for Cordova, and React Native will be much more faster in performance wise because there is no middle layer. Based on your need and your expertise, you can choose if you want to go with React Native or React. Both of them provide you ample support. It's just that React Native currently has support for Android and iOS only. So if you're planning to support multiple platforms other than Android and iOS, you can go for React. But if you're only concerned about Android and iOS as your major platforms, you can go React Native. So that basically concludes our session on React and React Native. If there are no more doubts, then I'll conclude the session.
Thank you, Subin. Thank you for today's session. And thank you, audience, for joining today's webinar. If you have any further queries or any further questions, you can connect with us at livesessions@aurelius.in. Thank you for your time.
Thank you guys for coming for this session.
Thank you so much, Sumit, for joining
If
us.
you guys
for
have
letting
any
us know
doubts
about.
regarding React and React Native, you can get back to Aarti and she can get back to me.
Thank you so much, Sumit, for taking your time, and now we are able to learn about React and Native.js. Thank you so much. Thank you so much, audience, for joining us. And for any queries, you can mail at livesessions@aurelius.in. Thank you so much all. Thank you. Thank you so much. Thank you.